Welcome back. Today we are going to start working on the LUV quests. And the first thing we want to do is to finish working on our Naquadah setup. That requires a precision assembler, so we craft a new one since the last one had been repurposed. But since we lack redstone, we shall make a new ore drilling rig first. And, to keep track of its progress from our base, we can use this new cover. We now have 3 miners and they are all out of drilling fluid. Maybe we have throttled the flow too much last time. And after increasing the flow, they are all working. And after not much time, we are ready to craft our new assembler. And we also are reminded on why we were feeding so little drilling fluid to the miners. Our ore processing plant is not being fed enough power. Since we have no hurry, we lower back the drilling fluid speed. Just kidding, we upgrade our mineral processing plant. The other thing we need is some precise casings for our new assembler. But those require a material which has to be cooked at ZPM voltage. Which, as usual, we will do by using 2 energy hatches of the previous tier. However, while this allows us to make the required material, it is also going to use half of our current power production. And our battery is quite empty already. So we quickly add some more reactors to our vacuum setup. Which fixed the issue. Until more machines turned on. Thus we also upgraded our fluid plant, starting from upgrading our heat exchanger into a Facafity XL, and, with an extra large heat exchanger, we also want to extra large turbine. With all that power, we can now run our volcanoes with 2 LUV energy hatches. And to keep up with those, we also got a mega vacuum freezer. That thing will cool 250 items at a time, but it also eats that much more energy. Thus causing huge power spikes that our battery can't alleviate easily. And the main issue is that it has no capacity. To craft better capacitor elements we need Naquadah alloy. And to be cooked we need even more Naquadah, enough for the coils of a whole EBF. So it is finally time to complete the precision assembler with precise casings that we planned a long time ago. And, with that, we can now craft the neutron activator required to complete our Naquadah processing plant. That machine does not require power, but it must be kept at a specific neutron kinetic energy in order to work properly. If we turn it on when outside of the recipe range, the ingredients will be turned into useless waste. To regulate the kinetic energy we can use neutron detectors, neutron accelerators and machine controller covers. Based on how high we build our neutron activator and how powerful the neutron accelerator, it will take more or less time to reach the target kinetic energy. Once we get there, we can start processing the Naquadah. And we must make sure the kinetic energy is kept in check by the covers. If it goes too high, the structure will explode. But what we are actually getting is Naquadah. That stuff can be easily converted into ingots or dusts, but we want to keep it like that because, in that form, it makes wafers 10 times faster. So, we quickly make patterns for the 3 main Naquadah forms and craft on demand the required version. And with all that Naquadah, we can upgrade our EBF so that we can craft some better batteries. And by swapping just 2 capacitors, we have 3 times the capacity. And now that our power issues are fixed, we can move on to the next task, crafting a fusion reactor. And just when we started working on the controller, we face our first issue: we lack indium. To get it, we have only 2 ways that aren't too convoluted. One is destroying more aluminium in the setup we already have. The other one is use the byproduct of Naquadah processing. Since we have some of that stuff lying around, we can work that to get some extra indium. And that is one energy-intensive job. But it already gave us enough indium for the reactor control computer. The next expensive thing we need is some superconducting coils, which are going to require more indium. Thus, we shall have more ore mining rigs across multiple dimensions to mine minerals that contain traces of indium. And, of course, to keep up with all of those minerals, we also want to upgrade our ore working facility, which is now becoming a huge source of pollution. The last component for our fusion reactor is LUV machine casings. Those are made entirely out of rhodium-plated palladium, which has to be cooked inside an EBF using some noble gas. But we run out of those gases. The easiest one to make is argon out of liquid air, however, our current setup is too slow. So, we shall swap our two small vacuum freezers with a big one that will work 250 times faster. And, after some time, we have finally completed our fusion reactor. Before we can use it, we have to wait for its 16 energy hatches to slowly load up its internal energetic buffer. Each recipe requires a specific amount of energy to be started. We are going to use this first reactor to constantly produce helium plasma. That stuff has a high energy density but requires a plasma generator. To make it, we need deuterium and either tritium or helium-3. Since helium-3 can be pumped from many planets, we chose that option. And we will want to use the highest tier of oil drilling rig, which, however, need at least IV power. And since our fuel is slowly depleting, we shall power that one with the plasma. But since we need its output for the plasma, we shall kickstart the loop by using some tritium. To get it, we manually centrifuge some deuterium from our new deuterium setup. We are not making this a definitive way of making plasma due to the awful production ratio of 16 hydrogen to 1 tritium. It indeed took quite some time for this tritium to be ready. And now, we can hit our fusion reactor with a hammer to turn it on, since there are no other power switches. Once the first plasma batch is done, we also manually fuse some europium. We need it to craft the plasma generator. Now we can go to Mercury, where we can easily locate some cheap helium-3 with our portable scanner. We build the oil drilling rig structure and set up a transceiver to swap fluids with the fusion reactor. And, once everything is ready, we can turn it on and realize that, once again, we have forgotten something to finish our building. This time, instead of flying all the way back to our base, take the missing pipes and come back, we use a Spectre key to open a portal to a pocket of space where we have access to AE2. While that does not look much different, consider that it takes about 1 minute to do the same task with a rocket. And now the pumping can begin. And with our new reliable source of portable fuel, we can start expanding our drilling capabilities. Meanwhile, our ore processing plant is expanding its pollution cloud, which is starting to make our green grass fall as sand. So we shall try to at least improve some mufflers. However, while those upgrades allowed us to gather the materials required for a second fusion reactor, we are also running out of power, again. To increase our production, we could burn some of the plasma that we are already producing, however, right now, we have no access to generators that can convert the energy at a high enough rate. Even the multi-block turbine is limited by its dynamo hatch, and the best we can craft only allows for 100,000 EU per tick. But I think that we could also look into some more imaginative power source, such as Naquadah. That stuff comes in different forms and can also be used in many ways. And I think the easiest way to extract its energy is to shove it inside some tungsten cells and then shove those inside our old vacuum-cooled nuclear reactor. It can be clustered in many ways, but I think we shall go with the one with the highest energy density. However, that thing is going to be quite complex to manage and quite interesting, so I think it shall have its own dedicated episode, where we will be trying some crazy stuff. You can wait for the finished result, or you come see the live streams to see the humiliating fails. Bye bye.